Welcome to the talk about Eclipse 4, the past, present, and future of the Eclipse application platform, or Eclipse platform itself. So let's start with introducing myself. I'm Tom Schindl, CEO of a co-founder of a small company located in Western Austria, Tyrol. I'm Eclipse committer on various projects at Eclipse. E4, Platform UI, EMF, lead two smaller projects at Eclipse and are part of the Eclipse Architectural Council. So a bit of history about Eclipse 4. So it was at EclipseCon 2008 where an announcement of the new E4 project was made at Eclipse. I was in the audience like you were and thought, oh, that's a good idea. We're using Eclipse. Let's see what I can do for the future of this amazing platform. So I came home from EclipseCon, and in May, Boris Bukowski and myself published the first prototype we thought the next generation of the Eclipse platform should look like. And we presented this, and in the end, it was the real prototype where the whole development of the new application platform started off, what you're now going to get as Eclipse 4 in about 2 months. In summer 2008, we published a tech preview where we tried out our prototype information and our prototype IDEs and released a tech preview which was not really usable. You could edit Java files, but many things didn't work. But we knew that our ideas and the technologies we are going to base our stuff on is going to work. It was a year of work simply trying out are the technologies we thought in the prototype are really usable to build the next generation of the Eclipse platform. In summer 2010, we published Follow SDK. It was a developer preview, so you as a developer could use it, but still many things didn't work. But it looked quite similar to the Eclipse IDE from the FieldX stream. Many key bindings didn't work, but it was really usable, and we started using it to develop Eclipse. So we started eating our own dog food and found out what things are really hurting and missing and got on with that. So since this time, we were really using Eclipse 4 to develop Eclipse 4. In 2012, we shipped a first, I'd say it's a beta release of the Eclipse 4.1 SDK. And now in 2012, the complete Juno-release train will be on Eclipse 4.2. So when you download Eclipse in 2 months, you get Eclipse 4.2 plus WTP plus PDT plus CDT, you name it in the end. But the platform beyond it is the new generation of the Eclipse platform. So did we only did this because we were funny people and say, okay, we want to do something new? No, there was a reason behind it. I simply took out 2 of them, but there are multiple. The first thing was that the programming model, which is below Eclipse, is really outdated. It uses a lot of singletons and statics. And statics and singletons bind you to a context you're in. You can't put a view part out and put it into a dialog, for example, because it uses statics, singletons, and it uses a lot of inheritance. So it derived from a base class which binds you to a certain context in the Eclipse IDE. There was the listener pattern. The listener pattern was really old and, in my idea, bad pattern. There are a lot better patterns to, like event buses, to send out information about changes in your system. So the listener pattern with listener 1, 2, 3, 4, 5, because we forgot one callback method, was simply, it's a pain in the ass in the end. So. And it was inconsistent. There were listeners where we send out strings and sometimes we send out objects. It simply was a mess. But the bigger problem that we have seen is that the architecture of Eclipse was built upon a system that we owned all your problems. Everything that you want to have the platform to do, even small things like I don't want to have drag and dropping view parts, which is quite common in RCP applications, that you don't want to have this feature, the platform team had to implement it for you. You didn't have the API or the possibility to implement it on your own. So we owned all the word problems. Every problem had to be solved by a team of 5 people. That scaled when there was 5 or 10 projects at Eclipse, but it didn't scale when we go to RCP with 1 million of developers and applications that all have different features they need from a platform. So we had to find a way that give you back the power that you can implement all the stuff. That's one of the biggest things, the biggest change we made in Eclipse 4 is this. So let's take a short look at the platform. The low level is completely the same. It's built on the GRE, it uses OSGi, and it's the first time that the platform itself uses EMF at the core level. So every application in future that uses Eclipse is using EMF, because it's in the low level of the application platform. And the Eclipse 4 application platform consists of 3 main parts. It's a workbench model, it's an EMF model that really makes up the complete UI. There is a dependency injection container running, so we're using dependency injection instead of the statics and singletons and inheritance and all this stuff, so we use DI, and we use services. Everything in Eclipse is a service. So the cool thing about service is you can exchange a service. If the service doesn't suit your needs, exchange it, put in your own service. But it's opaque to the platform. You simply have to implement the service interface, and the platform doesn't care that another service is running. On top of this one, you saw that the main application platform has no idea of SWT. The SWT is on the outer parts of the system. The core system is widget technology agnostic. Doesn't care about whether you're using SWT or Swing or Qt. You can do whatever you want. And the only communication you're doing with the platform is going through services. You only communicate with the platform through the service layer. There is no other thing to communicate between your code and the Eclipse platform. When I take a deeper look at the SDK level, we have, for example, PDE and GDT, two projects at Eclipse that provide you the Java tooling and the plugin development tooling. Beyond this is the so-called platform API. It's the view part, the editor part, the workbench window, and all the stuff. And below that, there's Equinox. When you take a look on the other side, on the present and the future, PDE and GDT are unmodified code bases. They program because all they are doing is calling an API called Platform API. And this API is 100% compatible between the 3.x platform and the 4.x platform. So the code up there is unmodified running in the new system, and so is your code. So if you develop something and using solely public APIs of Eclipse, everything will run on Eclipse 4 as it did on 3.x. That's one of the things we now worked 1 year. The year between 4.1 and 4.2 was 95% was in the so-called compot layer that make your plugin really run inside Eclipse 4.x. And in between, there's a new platform. You can call it RCP 2.0, which is the fundamental Eclipse platform. And we simply took the calls you're doing to the old platform and translated into call in this new, really thin and really expressive and cool new platform. The next slide shows that, in fact, the Eclipse 3.x platform and 4.x platform, only one plugin changed. That's the UI Workbench plugin. No other changes. SWT is the same, JFace is the same, core resources is the same. So let's take a look at the past, the present, and the future of the programming model of Eclipse. We started off with the past, where we had everybody who implemented a plugin for Eclipse know how it looks like. You derive from a base class, have to implement some methods, that's it. They have very long call chains often to get a service and all the stuff, and it derives from a base class. When we look at the present, it looks like in 3.x. In 4.x, we remove the extend. You don't extend from any base class anymore. All informations you want to have are handed over to you using so-called dependency injection. This makes your code, for example, much more easy to unit test. You don't have to bring up the framework You simply have to create an instance of my part, hand it over a composite, and run a unit test. No need to bring the complete platform up. The selection stuff is not that you have to get a selection service. No, there's a method that's called when the selection changes. You can hand it over. You can do that your own in unit tests using pure Java code. No need for anything else. No fancy stuff. So the future, what could the future look like? Dependency injection also means that we don't depend anymore that all your code is written in Java. You can use the language of your choice. That's the present, and this how it could look like in future. You could write your stuff in JavaScript. You only have to have a dependency injection system that knows how to read this stuff and create instances of it. The framework itself doesn't care anymore. So that's only an example. We have not implemented. That's future. It's up to you. You can implement it. We don't have to. But it's an idea, for example, if you don't want to use Java. So the next thing that I was in charge of at Eclipse 4 was the application model. And when we look at the past, we have the black hole, the Eclipse Platform. And there is one model that's based on Java. It's the Workbench Advisor, the Action Bar Advisor, the Workbench Advisor, and all other stuff. There's a second application model that's found in the XML stuff. It's a plugin XML where you define the extension points, for example, to contribute a view part. But the problem in here is the plugin XML is fixed. You can't add an attribute. You probably want to send in a view part and add another information when you configure the system. You can't do that with plugin XML. It's a fixed system. And the even worse thing is, this has been at startup, but at runtime, the Java model, you can't access it anymore. It's gone. Fairly all information, you created the actions and the file menus and all the stuff in the Action Bar Advisor. This information is not accessible to you anymore, because at runtime, everything is converted into a Java model. The plugin XML one is converted to a Java model. It's so-called registries and descriptors, and they are read-only. You can't modify them anymore at runtime. Most of them. There is some part that you can modify, but the bigger thing is you can't really add a view part at runtime simply by calling the registry and call add in there. So that's the black hole. You put in stuff and something gets out, but it's completely modified. There is no thing that is at design time and runtime are two completely different things. And we tried to unify that and did that in the present by creating a so-called application model that's built on top of EMF. This application model holds all informations you have in your workbench. It holds all information as you see there. There's a window, there are some sashes, there are some perspectives, there are some part stacks. This is an application model. It's the same at design time as it is on runtime. There is no break between those. And all informations, everything you want to access is part of this application model. If you want to know which commands are there, go to the application model. If you want to know what views or what stacks are there, go to the application model. It's the central point of information. You only have to access this application model. You can think of it like a browser DOM, where you have the DOM you can access and you can modify it. The cool thing is about this model, it's a so-called live model. Any change you make to this model at runtime is immediately reflected on the UI. I'm going to present this in a minute. This is how you interact with the model. The first thing is to close a part. You simply get the stack it's contained in, remove the element, the part is gone. The same is you want to change the title of a thing in your UI, simply go to the model, access the model element, set the label. It's similar to how you communicate or do programming in the browser. You simply interface all the time with this DOM. So what does this model help us to solve? Those two things are bug reports. The first two are for 3.x. The third one is for 4.x, but they request the same feature. The feature is that whenever you close the last element in a stack, like the outline view, that the stack, the area is still occupied by this stack, by this tab folder. These are quite easy things to implement, you might think. And you take a look at the code changes needed for this feature to implement in X. It was 7 classes involved, and for X, 2 classes. The code changes in X, lines of code, where 130 lines of code had to be changed to get this feature working. A really, really small feature. 4 lines of code in X. The time was not there when the initial thing was implemented, but I tried to fix a problem with it. It took me 3 to 4 days to find out I can't fix it. It's unfixable in X. You can't fix it. You had to change, I think, 20 or 30 classes, and even then it didn't work. In X, it took me 5 minutes to implement it. And the 5 minutes is because it's only 5 lines of code. When you look, that's the patch that implements the feature in X. The green lines are the new lines. That's the only thing I had to change. So it took me 5 minutes to implement something. It took probably around 2 weeks in X. And that's the real problem, or the real cool thing. And the really nicest thing would be, it wouldn't have to be us that implemented it. You could have done it your own if you want to have this feature. You didn't have to wait for upstream and wait for us to implement it for you. You could have done it on your own. Let's do a short demo about the stuff I'm presenting here. So here I have my Eclipse IDE, and you see in here, that's the so-called live model of your application. So, for example, let's switch from vertical to horizontal. You see, whenever I change the model, the UI reflects the change. You can interact with this model quite easy, as I showed. You can do so-called JavaScript execution on it. So this one now changes the title of the problems view, navigates to it, right? So just execute this one. You see down there the tab folder on the lower side changed to hello, and the focus was put in there. You can also remove stuff in there. So you simply interact with this model. So now the Javadoc folder is gone. That's the thing I showed you in Java code. You can execute JavaScript code as well on the model. That's simply no problem. So let's hurry up a little bit. The future. One of the future things, this is also a bug number. It's the most voted bug at Eclipse. It's caused about split editors. And it was filed in 2002. And it's a half a man work to implement this in X. Even then you didn't know. Probably we can do it, but the estimate is about half a year. So what did I do? I implemented this feature on top of X. This is an unmodified M7 build of 4.2. And I added a plugin that implements the feature. I can go now in here and press Ctrl+6. It splits the editor. You see, it's the same editor up there and up here. Everything is working. The outline view updates itself when you do switching between those editors. You see, the focus is going up there, but the outline view reflects all the changes. So I could implement the feature for you with, I think the first code came from Remy Suan, a committer at Eclipse for EclipseCon, and I modified it to make it work on 4.2 M7. The really important thing is that, I go back to my slides, yeah. That we will be able to solve problems we couldn't solve in X. And the even more important thing, it's not we, it's you. You can solve a problem that's really deep down in the Eclipse X platform. You can fix as a plugin developer in X. That's the main cool thing about Eclipse. And finally, I have some cool stuff to show off the new platform. The first thing is when you look at the service layer, I said you can simply exchange services. And one of those services, that's the translation stuff. So when a translation happens in your UI, then it's done by a so-called translation service. This translation service normally simply goes to property files on the file system, searches for a key, and translates it. You can simply go there, remove this one, and replace it through a service that goes to Google, takes the English string, translates it to any language you want to have. So I did that. And here I have some applications here. I have no idea of Japanese. I have no idea of, I think the middle one is Swahili. I have no idea of all the stuff. That's simply going, replacing a service and making it, replace the service that's in Eclipse, replacing it with something that does something better. And the last cool thing I can show you is that even cooler things are doable with this new platform. When I get it up and running, just give me a second. This is now an Eclipse 4 application platform that's not using SWT as a rendering technology, it uses JavaFX. Because I showed you the core platform itself has no idea of SWT. That's really a small application platform we showed off at EclipseCon, and the even coolest thing that we did in there was that we had this guy stored in a so-called CDO repository. It's an EMF model. I can store it in CDO. And now I have a second instance of the application, this time running on SWT, but they can communicate with each other. Whenever I move things in there, the other thing is moving. When I select an area in here, I can draw in here, save the guy, and the thing shows up on the other side. So there are many, many possibilities, the new platform. The platform itself has no idea about this. It's really once more done as a plugin. You can replace the stuff, and Eclipse Forward X will react as you want it. That's it. Just the final slide from myself. If you want more information, you can find on my blog, on the mailing list for Eclipse, or just send me a mail. Thanks. Any questions, or do you want to have coffee? Yeah.
Is it possible to have the slide presented in this course, or?
The question was whether we have some area for the slides. I think we'll send it to you, probably. Yeah. You have all the registration?
We will gather all the slides and put them on the website of the event.
You normally can always find the slides from my talks on my blog. I always put them up there. You can use them under Creative Commons non-commercial licensing normally. That's the thing about my slides. Yeah? Performance? We are yet a bit behind performance from 3.x to 4.x. But the cool thing about the platform is it always goes through the same areas of code. They're not so, the code base is really quite small. I think the complete size is, download size of the Eclipse 4 application platform is about, I'd say, about 1 megabyte of the complete platform when it's compiled. So we have really hotspots where we can really go in there and find out what's going on and really optimize the code in there. We don't have such a large code base where everything is federated around. So we hope we will not meet the goal that we are as fast at 3.x in the 4.2 release, but we still think that we can improve and make it as fast or even faster in some areas, at least. Some of the time is also, you saw the new styling, it takes some processor power. So that's only a thing that takes up a little bit of time. But yeah. Other questions? Thank you.